Welcome to BIM and AI in Practice, your go-to source for mastering Revit with confidence and clarity. We're excited to have you join us for the fourth episode of our Revit 2025 tutorial series. In today's session, we'll take a closer look at one of Revit's most versatile toolsets, the Annotate tab. Whether you're documenting designs or enhancing visual clarity, this feature plays a crucial role in your daily workflow. If you haven't had a chance to check out our earlier episodes, now's a great time to catch up. They lay the groundwork for everything we'll build on today. Whether you're an intermediate Revit user or just beginning to deepen your expertise, this tutorial is packed with actionable tips to boost your technical skills and modeling efficiency. Even seasoned professionals will discover strategies to optimize workflows, increase precision, and streamline documentation across disciplines. We regularly release in-depth practical content, so be sure to subscribe and check back often as we continue to explore the latest in BIM tools and methodologies. In today's fast-paced AEC landscape, staying ahead means embracing not only building information modeling, but also the expanding role of AI-driven design workflows. Let's get started by taking a closer look at dimensions, beginning with the diameters panel in the Annotate tab, an essential step in refining how we communicate design intent. A permanent dimension in Revit is a view-specific annotation that captures precise measurements within your model. You can place permanent dimensions using the Dimension tool, which supports several types, including aligned, linear, horizontal or vertical projections, angular, radial, diameter, and arc length dimensions. To see the actual dimension value, simply select one of the referenced components after placing the annotation. Before adding dimensions, it's often helpful to adjust their type properties. This allows you to define styles for each dimension type, such as aligned, linear, angular, radial, diameter, or arc length. When dimensioning elements like doors and windows, Revit gives you the flexibility to snap to either the edge of the opening or the center line of the component, depending on your documentation needs. How to add an aligned dimension? Aligned dimensions are used to measure the distance between two or more parallel references or between key points, such as the ends of walls. To get started, go to the Annotate tab, then click on Aligned in the Dimension panel. You can also use the Revit shortcut, DI for Aligned Dimension, a great time saver once you're comfortable with the workflow. Before placing the dimension, choose from a set of options, including wall center lines, wall faces, center of core, or faces of core. For example, if you select wall center lines, your cursor will automatically snap to the center line when you hover over a wall, ensuring accuracy in placement. Next, on the Options bar under Pick, choose Individual References. Now, move your cursor over a reference point on an element, such as a wall. When the point is valid for dimensioning, it will highlight automatically. Tip: press Tab to cycle through available reference points. Click to confirm your first reference. Then, move the cursor to the next reference point and click again. As you do, a dimension line will appear dynamically. You can continue selecting additional references if needed. Once you've placed all desired references, simply move the cursor away from the last element and click to finish. The permanent aligned dimension will now be displayed in the view. Now that you've seen how to place aligned dimensions manually, Let's take it a step further by exploring a faster method, adding aligned dimensions automatically. Revit also allows you to add aligned dimensions to walls automatically, streamlining the process with just a single click. This method is especially useful when dimensioning entire walls, walls with intersecting elements, or walls that contain openings. First, on the options bar under Pick, select Entire Walls. Next, click Options to open the Auto Dimension Options dialog. Here, you can choose from the following settings. Openings. Use this to dimension a wall and its openings. You can choose centers or widths as your reference. Selecting centers places the dimension string at the center of each opening. Selecting widths measures the full width of each opening. Intersecting walls. This option dimensions the selected wall along with any intersecting walls. When selected, Revit automatically generates a multi-segmented dimension string to include all intersections. Intersecting grids. Use this to dimension a wall in relation to intersecting grid lines. Revit will create a multi-segmented dimension string referencing the perpendicular grids that cross the wall's center line. Click OK, then select the wall you wish to dimension. Similarly, you can add a linear dimension to your drawing to measure the distance between two or more points. Many Revit commands have default keyboard shortcuts, while others do not. If a command doesn't have a shortcut, you can easily assign one yourself. To check whether a command has a shortcut, hover over it in the interface. The tooltip will display the shortcut, like DI for the Align Dimension tool. If nothing appears, that means no shortcut has been assigned yet. To customize your keyboard shortcuts, follow these steps. First, go to the View tab. Then, in the Windows panel, open the User Interface drop-down and click Keyboard Shortcuts. Next, in the Keyboard Shortcuts dialog, select the desired command from the assignments list and press the key sequence you'd like to assign. Now let's return to the Annotate tab and continue with the Angular Dimension tool. Angular dimensions are useful for measuring angles between multiple reference points that share a common intersection, such as walls that meet at a corner. First, click Angular in the Dimension panel. Next, move your cursor over a component and click to define the starting reference point. Tip: you can toggle between snapping to the wall face or wall centerline by pressing Tab. Then place the cursor on a second component that isn't parallel to the first, and click again. Finally, drag the cursor to adjust the size of the angular dimension and click to place it. Now let's break down radial and diameter dimensions, both essential when working with curves, circles, or arcs. These tools are widely used across drafting, engineering, and CAD-based workflows. Start with a radial dimension when you need to measure the radius of an arc. To do this, click Radial from the Dimension panel, then move the cursor over the arc. Tip: just like with linear and angular dimensions, you can switch the reference point between the wall face and wall center line by pressing Tab. Click once more to place the permanent dimension in the view. Similarly, diameter dimension to measure the full width of a circle or arc. This is especially helpful when detailing round elements like columns, pipes, or circular openings. Adding an arc length dimension. Use the arc length dimension tool when you need to measure the full curved length of an arc wall or other arc-shaped elements. First, click Arc Length from the Dimension panel and choose a snap option from the options bar that best fits your needs. Next, place the cursor on the arc and click to select the radial point. Then, click to define the start and end points of the arc. As you move the cursor away from the arc, you'll see the dimension line begin to take shape. Finally, click once more to place the arc length dimension in the view. We'd love to hear from you. Have you tried using arc length dimensions in your projects, or do you tend to stick with aligned and angular types? Let us know in the comments how you're using dimensions in Revit. And don't forget to like the video if you're picking up some new tips. Now that we've covered the core dimension types, let's move on to a powerful annotation feature in Revit, spot dimensions. Spot dimensions are used to record key data points in your model, such as elevation, coordinate location, or slope, all essential for communicating detailed site and design information. There are three main types of spot dimensions. First, spot elevations. These display the elevation of a selected point or both the top and bottom elevations of an element like a floor slab or wall. Second, spot coordinates. These show the north, south, and east, west coordinates of a selected point. Optionally, they can also include the point's elevation. Third, spot slopes, used to measure the slope at a specific point on a surface or along the edge of an element, such as a ramp or roof. Additionally, you can enable alternate dimension units to appear alongside your primary units for all spot dimension types. Helpful for projects that require both metric and imperial units. With a clear understanding of spot dimensions, let's take a closer look at one of the most commonly used types, spot elevations. Spot elevations are used to display the actual height of a selected point, making them essential for documenting vertical information across various elements like ramps, roads, toposolids, and stair landings. You can place spot elevations on both non-horizontal surfaces and non-planar edges, giving you flexibility when working with complex geometries. They can be added in plan views, elevations, and even 3D views, making them a versatile tool for documenting vertical data throughout your project. In addition, spot elevations can display the top and/or bottom elevation of elements that have thickness, such as floors, slabs, or roofs. These top and bottom readings are specifically available when working in plan views. How to add a spot elevation dimension. To place a spot elevation in your project, follow these steps. First, go to the Annotate tab and click Spot Elevation in the Dimension panel. Next, use the Type selector to choose the type of spot elevation you want to place. Then, on the Options bar, you'll find several key settings to adjust. Leader. If Leader is unchecked, simply click to place the spot elevation directly on the element. If Leader is enabled, move your cursor away from the element and click to place the label. For a leader with a shoulder, move the cursor, click once to place the shoulder, then move again, and click to place the spot elevation. Relative base. If you're placing a relative spot elevation, select a level to define the base elevation. Display elevations in plan views only. Choose top elevation to show the element's top level. Choose bottom elevation for the bottom level. Select top and bottom elevations to display both. After placing a spot elevation, you can adjust its position using the drag controls. Keep in mind, if the referenced element is deleted or its visibility is turned off, the spot elevation will be removed automatically. In the second part of this video, we'll dive into temporary dimensions and dimension properties. Two key tools that can significantly improve your workflow and accuracy in Revit. If you have any questions or need further clarification, feel free to leave them in the comments below. We'd love to assist you. Temporary dimensions. Temporary dimensions in Revit are designed to quickly snap to the nearest perpendicular element and adjust by a specified value. Once you place an element, temporary dimensions will display automatically. However, once you place another element, the temporary dimensions for the previous element will no longer be visible. To view temporary dimensions at any time, simply click Modify and select the element. Keep in mind, temporary dimensions will always measure to the nearest element, so the values might differ from the initial dimensions you saw. Tip: if you want to keep dimensions displayed permanently, you can create permanent dimensions instead. Customizing temporary dimensions. You can also adjust the size and background of temporary dimensions in the Options dialog under the Graphics tab. Modifying these settings will also change how text is displayed when using the Measure tool. Setting temporary dimension preferences. You have several options for setting where temporary dimensions measure from. A. You can set them to measure from wall center lines, wall faces, center of core, or core faces. B. You can also adjust them to measure from door and window center lines, or even from door and window openings. How to specify temporary dimension settings. To customize your temporary dimension settings, follow these simple steps. First, click the Manage tab, and under the Settings panel, click the Additional Settings drop-down. From there, select Temporary Dimensions. Next, in the Temporary Dimension Properties dialog, choose the settings that best fit your project requirements. Finally, click OK to apply the changes. Temporary dimensions. Let's shift focus to dimension properties, another powerful tool for customizing your Revit project. What are dimension properties? With dimension properties, you can fine-tune the appearance of various dimension types, such as dimensions, spot elevations, spot slopes, and spot coordinates, to align with your organization's standards and industry requirements. You can control everything from leader types and line weights to a variety of other dimension display properties, giving you full flexibility over how your project details appear in the final documentation. To begin, go to the Properties panel and click Type Properties. One of the key settings here is Dimension String Type, which defines how a string of dimensions is formatted. This option is available specifically for linear dimension styles. You'll find three main formatting options. Continuous places multiple dimensions end to end along a single string. Baseline creates stacked dimensions that all measure from the same starting point or baseline. Ordinate displays values measured from a fixed origin, typically used in manufacturing or precise layout workflows. Leader type. Another important setting within dimension type properties is the leader type, which specifies the style of the line connecting the dimension text to the dimension line. You have two main options to choose from. A. Line. This draws a two-part straight line leader. The first segment starts either at the text box or under the text, depending on the text location property. It extends to a junction point called the shoulder. The length of this segment is controlled by the shoulder length property. The second segment extends from the shoulder to the dimension line itself. B. Arc. This option creates an arc-shaped leader, curving from the dimension text to the dimension line for a more dynamic visual connection. Tick mark specifies the style of tick mark used at the ends of dimension witness lines. This setting controls the graphic symbol, such as an arrow, slash, or dot, that appears at each end of a dimension line. You can choose from Revit's built-in styles or create a custom tick mark to match your project's graphic standards. Line weight determines the thickness of the dimension line and the leader line by setting a specific line weight number. Higher values result in thicker lines, which can enhance visibility in printed drawings or help distinguish key dimensions in complex views. Tick mark line weight specifies the thickness of the tick marks at the ends of dimension witness lines. You can choose from a list of predefined line weight values in Revit or define your own, allowing you to match project or organizational standards with precision. Witness line control. This setting determines how witness lines behave in relation to the element being dimensioned. You can choose between two modes. Gap keeps a consistent distance between the witness line and the element, regardless of the dimension text location. Fixed dimension line keeps the dimension line in a fixed position, allowing the gap between the witness line and the element to vary. Text formatting. You can customize the appearance of dimension text by adjusting settings such as font, text size, and style, including options like bold and italic. These changes help maintain consistency with your project's documentation standards or match your company's branding requirements. Format. In this section, you can define how units are displayed in your dimensions, schedules, and labels. Whether you're working with length, area, volume, angle, number, currency, or slope parameters. When you click Units Format, the Format dialog appears. By default, the Use Project Settings option is enabled. This means the value will display according to the global unit settings defined for the project. First, uncheck Use Project Settings to customize the unit format for the selected parameter. Then, from the Units menu, select the unit type that best fits your parameter, such as meters, feet, or degrees. From the Rounding menu, choose how precise the value should be. You can also select Custom and enter a specific rounding increment. If needed, you can select a unit symbol or unit suffix from the drop-down menu for added clarity. Once you're done, click OK to apply the changes. Displaying alternate dimension units. Revit allows you to display alternate dimension units alongside the primary units for all permanent and spot dimension types. This is particularly useful when you want to display both imperial and metric units in a single dimension string, ensuring clarity for diverse audiences. For example, in this case, we'll modify the aligned dimension type to show alternate units. To display alternate units, first, specify whether to display the alternate units in line to the right of the primary units or below the primary units, depending on your preference. Next, click the button next to the Alternate Units Format property to define details such as the units, rounding, and whether to include a unit symbol. You can apply this feature to customize the unit display for other dimension types as well, ensuring consistency and clarity across your drawings. How to change project units. The units for a project are initially set when you select a project template. However, for an existing project, you can easily adjust the units using the Project Units tool found under the Settings panel on the Manage tab. To change project units, first, click the value in the Format column for the unit type you want to modify. Second, In the Project Units dialog, you can specify a format for each unit type independently, such as length, area, volume, angle, and more. Next, adjust additional settings like rounding, symbols, and other formatting options to match your project's requirements. Next, set all options as desired for each unit type and click OK to apply the changes. This allows you to maintain consistency in your project's unit system, whether you're working in metric, imperial, or a combination of both. Architectural education isn't just about understanding design theory. It's about merging creative thinking with technical problem solving. Together, these elements allow us to shape spaces that significantly impact how we live and work. Tools like Autodesk Revit are not just pieces of software. They are essential components of our digital design process. Revit empowers us to transform abstract ideas into functional, buildable solutions, reinforcing the connection between creativity and construction. Thank you for joining us for Part 4 of our Revit 2025 series. We've covered a lot of valuable insights today, and we hope they've been both practical and inspiring for you. If you missed Parts 1 through 3, we highly recommend going back to watch them. They provide the foundational context that enhances today's discussion. Be sure to tune in next week, when we'll explore even more advanced features of Revit 2025.